Hey all, this is the Unit 1 review packet guide for Algebra 2 Honors. So if the answer key was not clarifying enough, this is another resource you can use to make sure you're all good to go for Friday. Okay, let's get started. So this is a new version of the quiz you took, just to give you like another chance at that in case any of that was unclear to you. We have a circle with endpoints -2 and 8, 5. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So we have this diameter across, and then roughly we'll just sort of sketch a rough circle here. Okay. We want to find the center of the circle using the midpoint, so we're looking for somewhere in the middle here. We're going to use the formula for the midpoint, which is x1 plus x2 over 2, comma y1 plus y2 over 2. And when we plug those points in, right, so if we look up here, we can make this our x1, x2, y1, y2. You will get 6 over 2, comma 3 over 2, which just simplifies to 3, comma 3 over 2. Okay. Now finding the radius of the circle. So radius, right, that is not the diameter, that is the radius, that is half of the diameter. Just because this is a fraction in it, and that adds a little bit of messiness to it, what I'm going to do is find the length of this diameter, and then I'm going to divide it by 2. So we use the distance formula, which is the square root of x1 minus x2 squared plus y1 minus y2 squared. This is 10 squared plus 7 squared, which is the square root of 149, where this is the diameter. Okay, so the radius is root 149 over 2. Radius. Okay. Write the equation of the circle in standard form. So we have for the standard equation for the circle is x minus h squared plus y minus k squared equals r squared, where h comma k is the center. Okay, so when we plug that in, we're going to get x minus 3 squared plus y minus 3 halves squared equals our radius, which is root 149 over 2 squared. Okay, that's it. So here we have an equation. This is in standard form. Right. So whenever we want to find the y and x-intercept, you're plugging in values. Right? So for the y-intercept, x equals 0, right? So we set x equals 0, so that means that 6y equals 18, so y equals 3, so it would be at 0, 3. And if it's the x-intercept, then y is 0, so we have 2x equals 18, x equals 9, so it's 9, comma 0. And we're going to go ahead and plot this. We're going to get 0, 3, 0, 1, 2, 3, and 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can just sketch a line through these points. Not perfect, it's okay. Okay. We are now looking for a perpendicular line, the equation of a perpendicular line to this standard form that intersects -6, 2. So whenever you see sort of a point that's going to intersect a certain point, this means like a point slope is very helpful for that, right? Because we can do point slope form is again x minus y minus y1 equals mx minus x1. So we can say, okay, y minus 2 equals some m, and then x plus 6. So all I'm missing is my m, or my slope. There's a number of ways you could get the slope. Remember that you could get rise over run from this, and so you could do sort of, y2 minus y1 over x2 minus x1. That will get you the slope. Also in standard form, negative a over b is the slope. So that means that here, negative a over b, that's negative 2 over 6, so that's just the same as negative 1/3 equals m1. And just like a good idea to like look at the graph. So does that make sense? Yeah, that makes sense. Like I can see it's going down 1 over 3, and that matches this. Also really important, like probably one of the most common mistakes in the quiz is just like not reading the question carefully. Perpendicular, not parallel, perpendicular. So we want the negative reciprocal. So that means M2 must be 3. So therefore right here it's going to be a 3 in here. If it was parallel, it would be negative 1/3. If it was perpendicular, it would be 3. Okay, that was 1.1 to 1.3. Moving on, we got some quadratics. So solving 3 different ways. First by factoring. Again, you all might have a method that works for you, and I'm gonna do what works for me. This is by factoring. That's the important part. As long as you're factoring, you're good to go. So the way I solve these is I use the box method. I put 2x squared up here. I put negative 2 down here. And I'm finding, I know this has to be 2x and x. I'm finding 2 numbers that when I combine these 2, they're going to add up to 3x. The combination that works is a -1 here and a 2 here. That way we'll have a 4x and a minus x here. Those 2 add up to 3x. These 2 multiply to negative 2. So we got it. It's 2x minus 1 and x plus 2, which means that x equals 1/2 and x equals negative 2. Completing the square. Steps to completing the square. You get rid of the constant and move it to the other side. So we're going to have x squared plus 2x equals 3. Then you take the b, right? So b is 2. You divide it by 2. b over 2 is 1. And then you square it. b over 2 squared equals 1. And you add that to both sides. So we're going to add a 1 and add a 1. And we're going to get x squared plus 2x plus 1 equals 4. This is now a perfect square, and we can rewrite it as x plus 1 squared equals 4. Then, I'm going to rewrite it up here. X plus 1 squared equals 4. You're going to square root both sides. So we're going to have x plus 1 equals plus or minus 2. I'll write 2 equations out. We're going to have x plus 1 equals 2. X plus 1 equals negative 2. X equals 1. And x equals negative 3. And you can always plug them back in to make sure it's going to work. Okay? That is completing the square. So get the constant to the other side, find b over 2 squared, add that to both sides, make it a perfect square, square root both sides, solve the 2 equations, and you can practice this on delta if you're still unsure about that. Solve for x using quadratic formula. Okay, so quadratic formula we know is negative b plus minus square root b squared minus 4ac over 2a. Just make sure you got that down, have it memorized. So it's going to be negative 7 plus minus the square root of 49 minus 4ac is going to end up being a plus 32 over 4. This will simplify to negative 7 plus minus root 81 over 4. And this simplifies to, so you have negative 7 plus 9, right? It's negative 7 plus minus 9 over 4. And you get x equals 1/2 and x equals negative 4. Okay? All right, complex numbers. So when the adding and subtracting ones are pretty straightforward, these two. You're just combining like terms. Like you imagine it like it's an x, right? Like an 8x or 7x. You're just combining the two. So here when you combine like terms, you get negative 1 minus 15i. When you combine like terms here, you get negative 3 plus the 12i. Nothing too much here. Just make sure you're distributing this, right, to both of them. These two are a little bit more challenging. The main thing you need to remember is that I squared equals negative 1. So whenever you see an I squared, you convert. Okay? So here, 6 plus 4i squared. We're going to do a little box. 6, 4i, 6, 4i. You get 36 and 24i and 24i and then 16i squared, which remember that's just 16. So when we add it all, or negative 16. So when you add it all up, you get 20 plus 48i. Okay. The division, right? Instead of really dividing, you're simplifying instead of dividing, and we're simplifying by multiplying by the conjugate. So you want to look at the denominator, look at this, right? And you want to get the conjugate. To get the conjugate, you're just going to change that middle term to either positive or negative. You're going to flip the sign of this middle term. So our conjugate is negative 3 plus 3i. Not 3 plus 3i, negative 3 plus 3i. This sign does not change. Okay? Then we're going to multiply across. So we're going to have negative 3 plus 7i over negative 3 minus 3i times negative 3 plus 3i over negative 3 plus 3i. And when you do this, and you can do this just by box method or by foiling, you're going to get 18 on the bottom, and you're going to get negative 12 minus 30i on top. Okay? So make sure, like, if like on these problems, like, show your work. You can do the box method, right? You're not too good for the box method. You can do it, and make sure it's right. Okay? Got it? All right. I to the 66 and root negative 5. So whenever you have I to like some big number, you just take this big number, do 66, you're going to divide it by 4. When you divide it by 4, and you can use a 4-function calculator for this, you can see that it's going to be, I think it's 16, yes, 16? Let's make sure we're right there. 66. Right. You use a 4 function, but it'd be 66 divided by 4. Yeah, 16.5. So it's 16 remainder 2. And basically that remainder is what helps you. That becomes your new exponent of I, which then becomes negative 1. Okay. So just again, conceptually what's going on here, you have I to the 4th. That's why we divide by 4. We know I to the 4th equals 1. And we can rewrite I to the 66 as I to the 4th times I to the 4th, like 16 times. So it's like 1 times 1 times 1 times 1, 16 times. And at the very end, you have I squared. And so the I squared is what it equals, because all the other ones are 1. Okay, root negative 5 can be rewritten as root negative 1 and root 5. And that is the same as I times root 5. I cannot simplify 5 anymore, so it's just going to be root 5i. Okay, separately. I is not inside that root. Okay, we are on other equations. So this was the, 1.6, 1.7, maybe like one of the more challenging sections, because this is when I was gone for one of my classes, and there's a substitute, and there's a video for that. Let's go over these. So we have, first, this is factoring by grouping. I mean, I can identify that because there's 4 terms here, and I cannot take out any common factor. We separate the expression into groups. We take out the greatest common factor of those groups. So we have x squared, x plus 3, and then 16x plus 3 equals 0. We can rewrite this as x squared plus 16 times x plus 3 equals 0. So then our solutions are x equals negative 3, and then we have x squared equals negative 16, so x equals plus or minus 4i would be the complex solution, and then this would be the real solution. Okay, when you square root the negative 16, I'm doing what happened right here. So when you square root the negative value, the root negative 1 comes out as an I, and then you just take the root of the 16, so it's 4. Okay. Here, it's to the 3rd power, but each of these I can take out a common factor out of all of these, so I can take out a 2x here, so we have 2x, x squared minus 10x plus 24 equals 0. Then I can factor it again, x minus 6, x minus 4 equals 0, and so we have 2x. So our solution is going to be x equals 0, x equals 6, and x equals 4. For this one, this is a substitution problem, so we have w equals x squared. We're going to substitute w in for that. It's going to be w squared plus 11w plus 24. Now it looks like a quadratic, and I can factor it. W plus 8, w plus 3 equals 0. It's the same as x squared plus 8. x squared plus 3 equals 0. I mean, if this is factored completely, so technically I would be done kind of here, but I'll show you how to solve this completely. You'd get x squared equals -8, and x squared equals -3. So x would equal plus or minus 2 root 2i, and x would equal plus or minus root 3i. Okay. Here is a radical expression, a radical equation. We're going to square both sides to get rid of the radical. So we get 32 minus 7x equals x squared minus 4x plus 4. We'll get everything on one side. So we got 0 equals x squared plus 3x minus 28. We get x plus 7, x minus 4. So x equals -7 and x equals 4. But when you need with radical, let me write this above. So radical, rational, and absolute value, you need to check for extraneous. Okay, I will talk about that, but basically, in this case, I could get an answer that just doesn't work when you plug it in, because you're going to get you're going to get an imaginary number, or it's not going to work out. Okay, so in this case, when I plug in the 4, it works out okay. You're going to get 2 on both sides. But when you plug in a -7, you're going to get 32 minus 49. 32 minus 49, which is, you're going to get 32 plus 49, which is 81, but a -7 minus 2 is a -9. See what I'm saying? So in this case, -7 is extraneous because that doesn't match. It's saying that root 81 equals -9, and that's not true. Root 81 does not equal -9. So this right here is an extraneous solution. Okay. Again, just to clarify that, it's extraneous because when I plug it in here, it is not true. When you plug it in back into the original, it is not true. That's extraneous. 16. This is a rational. Okay. These are rational. Also, one that you need to check for extraneous on, you want to multiply by the lowest common denominator here. The lowest common denominator, okay, we have x minus 1 here. We can factorize this to be x times x minus 1. Therefore, our lowest common denominator is x times x minus 1 because it goes into both of these. Okay, so it's x minus 1. We're going to multiply everything by that. So we're going to get, when you multiply everything by x minus 1, you're going to get 6x squared minus 4x squared minus 4x equals 6. You'll get 2x squared minus 4x minus 6 equals 0. Factor 2x squared minus 2x minus 3 equals 0. 2x minus 3x plus 1 equals 0. So my solutions are x equals 3 and x equals -1. And when you plug them back in, they do work. So you're good. Inequalities. These you just solve like regular equations. This is just 6x less than or equal to -4, x less than or equal to -4 over 6, x less than or equal to -2/3. The only thing to remember really is that whenever you divide or multiply by a negative number, you're going to have to flip the sign. Do not forget that. Do not forget that, guys. Whenever you divide or multiply by a negative number, you flip the sign. Still see people would forget that. Here, you just do the same thing, but to both sides here. So you're going to get 1 less than or equal to 3x less than or equal to 15. So 1/3 less than or equal to x less than or equal to 5. Hey. Sorry, I'm just recording a video. Okay, on the next one here, we have an inequality. To solve this quadratic inequality, you want to set we want to find the solutions of it first. So we're going to factor this. X minus 6, x plus 3 equals 0. Solutions are x equals 6, x equals negative 3. We draw our number line, negative 3, 6, and then we test. So you can test a number below, in the middle, and above, and see if it's greater than or less than 0. When you do that, you see that it's less than 0 here, it's greater than 0 here, it's greater than 0 here. So your solution is negative 3 to 6. And that this bracket here is coming from this less than or equal to sign here. Okay. Here we have a word problem number 20. It's an inequality. It's saying when will the ball be at least 32 feet above the ground. So we're setting this 128 plus 16t minus 16t squared to be greater than or equal to 32. We're going to set that equal to 0, move around the terms, and I'm going to write it as 16t squared minus 16t minus 96 is greater than or equal to 32. Take out the 16, t squared minus t minus 6. Sorry, this is 0 here. Greater than or equal to 0. And then 16, t minus 3, t plus 1. Sorry, this is where I made a mistake. T minus 3 and t plus 2. So your solutions are t equals 3 and t equals negative 2. Also in this one here, this is 6x for this is positive. Sorry, this is a positive 2/3. This is x less than or equal to positive 2/3. Down here, we have our number line, negative 2 to 3, but remember, so time starts at 0, so we don't really consider negative 2 as an option. When you test these into this equation, it's going to be greater than here, less than here, and less than here. But again, because we don't count negative time, it's going to be from 0 to 3 brackets, because it's less than or equal to. Okay. Nearly there. 21. We solve these are absolute value, right? You make two equations. You want to get the absolute value alone first, so it's going to be absolute value 8 minus 4x I'll put the 2 in front. I'm going to rewrite this as equals 14. So I move this to the right, I move that to the left, and divide it by 2. We'll write two equations. So we'll have this will be 7 equals absolute value 8 minus 4x. So we'll have 7 equals 8 minus 4x, and negative 7 equals 8 minus 4x. And then solutions are x equals 1/4, x equals 15 over 4. And we test them in, they work just fine. Same idea here, you just subtract the 4 first. 3x plus 8 equals x minus 4. Two equations, you have 3x plus 8 equals negative x plus 4, and 3x plus 8 equals x minus 4. Make sure to make the whole thing negative. You distribute the negative to the whole thing. We get two solutions from this. We get x equals negative 6 and x equals negative 1. However, when you put these back in, it tells you that an absolute value is equal to a negative number, so these are both extraneous, and there's no solution. Right? Make sure that makes sense. If I put in a negative 1 here, that will be positive, and that will be negative. That cannot be true. An absolute value cannot equal a negative number. This is the same as this one, so we forget about it. And then 24, very similar to the quadratics, you get it alone, you get absolute value alone, so it's x plus 4 greater than 12. You solve it, x plus 4 equals 12, x plus 4 equals negative 12, x equals 8, x equals negative 16, number line, negative 16, 8, test the points, plus, minus, plus. So your solution is negative infinity to negative 16, and 8 to infinity. And when I say test the points, you take some point between these two, and you plug it into this, and see if it's greater than 12. It's a minus if it's not, it's a plus if it is. And we're done.